Good evening, everyone. We are in the week 3 problem solving session of the NPTEL course Basic Electrical Circuits, and week 3 is about power and energy in electrical elements and circuit analysis methods. Let me share my screen. So first, I'll be briefly discussing about a few aspects of power and energy in circuit elements, various circuit elements like resistor, capacitor, inductor, voltage source, and current source. And then we'll discuss a few basic aspects of circuit analysis methods, which Sir has mentioned in this week's video lectures. After that, we can start doing problems, and yeah, I'll try to wrap it up quickly because you already know like power and energy in circuit elements, but I'll just brush up the theory and I'll summarize it so that if you have any doubts, you can ask. And before going to problem solving session, we'll have uh, good clarity about the concepts that were taught this week. So I'll start with power and energy in any element. So you're able to see my screen, right? Hello.
Yes, we can see.
Okay, okay,
We can see the screen.
okay. Thanks. So if we consider any circuit element, say it could be resistor, inductor, or capacitor, or any voltage source, any element, and I'll represent it as a two-terminal element because it has two terminals, and say the polarity of the voltage is V, and say current is entering into that element, then the power is defined as, say, V and I are function of time. So I'll mention V of t, I of t, which is a generalized statement. It could be constant or it could be varying. Say if it is an inductor, it could vary. If it's a resistor, it is dependent directly on voltage. So I'm applying a time varying voltage, or you can say there is a time varying current flowing through the element, and that's why I'm assuming both are time varying just to be generic. So the power can be written as P of t is equals to V of t into I of t. So power is nothing but product of voltage and current. That's how it is defined. Now, if we come to energy, it is the integration of power. So the energy that is uh, consumed or supplied. So it is like power can be either delivered or it can be uh, dissipated. If it is a resistor, it is dissipated. So whether it is taking absorbing the power or delivering the power, that we'll get to see. So if for this convention of power, there can be two scenarios, right? One is P greater than 0, one is P less than 0. What does it mean by P greater than 0? It means power is positive, so voltage and current are positive. It is like there is a positive voltage across that element and it is drawing the current. So it is like consuming the power. So it is absorbing power. So we'll say it is absorbing power. If power is negative, what does that mean? One of the quantity is negative. Say I'll take voltage is in the correct polarity and current is in the opposite direction, which means the current is coming out from the element. Say voltage source, it is supplying the current, right? So current will be out from the element. So it will be giving the current to some other element, resistor or inductor. So that's why if the power is negative, it means it is delivering power. And kindly note the convention. These delivering power, absorbing power are according to the convention that we have drawn here, because we have considered the current is entering. So it is like if the current is entering this with this voltage polarity, it means that the element is absorbing the power, and with this voltage polarity, if the current direction is in the opposite way, then it means it is delivering power. So we'll get to see which elements can deliver power, which elements can absorb power, and then we'll go into more discussion with this power and energy of different elements. Now, if we talk about energy, so energy is defined as integral of power. So if we say what is the energy consumed or delivered by this element from this time to this time, then we'll say the integration of power with that integral limit. So for the time being, I'm assuming that the energy is delivered. So or it can be absorbed also. So let us energy absorbed or delivered by the element from time event. So when we say energy, it is dependent on the time. So we have to mention what is that interval of the time, because you can say energy is equals to power into time. If time changes, energy changes. So you have to mention what is the time interval within which the energy is either absorbed or delivered by this element. So it is dependent on the time. So in the question also they'll give what is the energy delivered or absorbed by this element from say t equal to 0 seconds to t equal to 1 microsecond or 2 microsecond. So that's why they will always mention the time from time t is equals to say t1 to t is equals to t2. So we'll write E of t energy is equals to integral p of t dt. So it is an integration of power from time t1 to t2. T1 could be 0, T1 could be non-zero. They can ask what is the energy from 1 microsecond to 2 microseconds. So that's why I have taken a generalized time T1 and T2. Now, what are the units of power? Anyone? Hello, what are the units of power?
Watts.
Yes, watts. Someone also mentioned in the chat watts. Yes, watts, and it is represented as W. And what is the unit of energy?
Joule.
Joules. Yes. J. Yes, joules. So this is how power and energy are related. Power is nothing but a product of voltage and current. They could be time varying, they could be constant, and energy is the integration of power. Good evening. Yes, good evening, Gayatri. If you have joined late, I'm just summarizing what we have discussed. Basically, we have started with power and energy in any random circuit element, and we have taken this convention of voltage and current polarity. This is how we have defined, and according to this voltage and current convention, we have defined the power. So, power is defined as P is equals to V into I of t. V of t into I of t, assuming voltage and current are time varying. And if power is greater than 0, then it means the element is absorbing the power. And if power is less than 0, it means the element is delivering the power. And when I say circuit element, it could be resistor, inductor, capacitor, voltage source, or current source. And the units of power are watts, and energy absorbed or delivered by this element from certain time interval to certain time interval is just the integration of power with respect to time in the given specified time intervals, and the units of this energy are joules. And joule is nothing but 1 joule is equals to 1 watt second, because energy is power multiplied by time. So 1 joule is equals to 1 watt time 1 second. Similarly, 1 watt is equals to 1 volt times 1 ampere. Or you can say I square R. So it is 1 ampere square times ohms. Okay. Now we'll consider power and energy in resistor. We'll summarize. I will not go into more details, but I'll just quickly write the formula so that we'll understand it easily. So first we'll take power and energy in a resistor. So let us consider the resistor. Polarity is say V, the current is I, the resistor value is R. Then according to our formula, power is nothing but V into I. And we know that from the Ohm's law, that I is equals to V by R, right? So I is equals to V by R, which is nothing but V square by R. Or if you substitute V equals to I here, you will get I square R. So in a resistor, power is defined as either V into I or V square by R or I square by R. Sorry, I square into R. So any of this formula you can use. If current is known and resistance is known, you can use I square R. If current and voltage are known, you can use V into I. If voltage and resistance are known, V square by R. So you can use any formula to get the power. And according to this convention, whether the power is greater than zero or less than zero, resistance is positive, and I square is also a positive quantity because it's a square of a positive or negative number. So square of any real number is positive. So this is a positive quantity. Do you agree? Hello, hello, anyone? Yes. Yeah. So we can say that here P is greater than zero because I square is always a positive quantity. So it means it is always absorbing power. And how does it? What does it do? By absorbing the power, it dissipates as a heat. So all the power it takes, it dissipates as a heat. If you have worked in any of the labs with the big resistors, you can always see when the circuit is on for a lot of time, they get heated and you can feel the heat depending upon how much power it is dissipating. So if you have performed in any of these electrical labs, you might have noticed that these big resistors, that big coils where you move that bar to change the resistance, they'll get heated with time because they're constantly dissipating the power as heat. So the power, all the power that they're taking, absorbing, they dissipate it as a heat. So they get heated up. So that's why if you keep it for a long time, the temperature will increase and you can, if you touch it, it will be very hot. So power, it is dissipated as heat. So now if I talk about energy, what is energy? Energy is equals to integral P of T into dt. So P of T is what? I'll use I square R, I square of T into R into dt. So I can write it as R into integral I square of T dt. Okay. So what is integration of some quantity? It is area under the curve, right? So what I square of T is always positive, agree? Which means it is always above the x-axis because it's always a positive quantity, right? If everything is above the x-axis, then what does it mean? The area under the curve is also positive. Agree? Agree? Anyone? Or any doubts? Hello.
Yes,
Did
sir.
you? Okay. So
Yes,
when
sir.
the energy is positive, it is called a passive element because it is always absorbing the energy. It cannot deliver energy. So what all the elements that can only absorb the energy, they are called passive elements. So energy is positive, which means it's a passive element. So when does the passive an element can be passive? When it's only absorbing the power. So power is greater than zero. Integration of that is also positive. So that's why it is passive element. So let us write the definition. A resistor can only absorb power or energy, I should say. and it cannot deliver energy. So that's why it is called a passive element. So the if you consider the IV characteristics of a resistor, it will be something like this. This is I, this is V. So if you see here, I is greater than 0, comma V is greater than 0. So that's why P is greater than 0. Here I is less than 0, comma V is less than 0. That's why P is greater than 0. Because if both are negative, then still the product is positive. So that's why it is here also absorbs power. Here also it absorbs power because power is greater than 0, and that's why it always absorbs power and it cannot deliver power. Is it clear until this point about resistor? We have initially started with the basic knowledge that we know P is equals to V into I, and using Ohm's law, we got three such expressions, and we have seen power is greater than 0, which means it only absorbs power. And what does it do with absorbing power? It dissipates as a heat. Then we have seen the energy, which is integration of power, and we have seen that energy is always greater than 0. And when energy is always greater than 0, it means it's a passive element, means it can only absorb energy and it cannot deliver energy. So that's why it is a passive element. Is that clear? Sir, if L deliver power, but why L is not active device? Very good question, Pagin. I'll come back to that point. Uh, Now I'll discuss about capacitor. Then same thing with the capacitor and inductor. Why they are not active elements and why they are passive elements. So the definition is this: if energy is positive, it is passive element. If energy can be negative, it means it can deliver energy. If energy is always positive, it means it can only absorb energy. So that's why it is called passive element. But if we can prove that energy can also be negative, then it means it can be a negative. I mean, it can deliver energy, and then we can say it is an active element. So we'll come back and see why it cannot be done and why it is passive element. So now we'll go into power and energy in resistor is done. So power and energy in capacitor. I'll do it quickly. Power and energy in a capacitor. So first we'll take the formula that is that by which how like the formula by using which the power is defined, which is V into I. Then V of t, I of t, and C. Then we'll use the IV characteristics of C and substitute in it. So power is nothing but power P of t is equals to V of t into I of t, which is nothing but what is I of t of a capacitor? Anyone? What is I of t for a capacitor? The IV, someone has mentioned in the chat box, C dV by dt. Yes, you're right. Is C into dV of t by dt. So now we'll get P of t is equals to C into V of t into dV of t by dt. So tell me, can this be only positive or it can be negative or what do you think? Can it be positive and negative? Like is there any scenario where this can be positive or is there any scenario where this is negative? Any comments or any idea? Like what do you think? Anyone? Any idea? Like do you think this can be positive or this can be negative or
Charging and discharging.
yes, it can be charging and it can be discharging depending upon the sign of VFT. Yes? Yeah? Anyone saying anything? Okay. So V of t can be positive, V of t can be negative, dv of t can be positive. I mean, different derivative of V of t can be positive, can be negative. So how many such combinations we'll get? We'll get such four combinations. So let me write that down quickly. So we'll get V of t, we'll get dv of t by dt, and then we'll get p of t, and then we'll say delivering or absorbing power. Okay. And how many such we'll get? We'll get such four. We'll see. First one, serial number one. Let we'll use the below one. So serial number one. Say this is greater than zero, and this is also greater than zero. Then what? Then serial number two. This is greater than zero. This is less than zero. Serial number three. This is less than zero, and this is greater than zero. And serial number four. This is less than zero, and this is also less than zero. Okay. Agree? Four such possibilities can be there. Agree? Hello.
Yes, sir.
Okay. So now P of t is product of these two. So if both are positive, it is positive. If one is positive, one is negative, negative. If one is negative, another is positive, negative. If both are negative, still positive. So if power is greater than zero, then it is absorbing power. If power is less than zero, it is delivering power. Similarly, if again it is negative, so it is delivering power. And again, if it is greater than zero, it is absorbing power. So we got four scenarios. And out of those four, in two cases, it is delivering. And in other two cases, it is absorbing. Is it clear until this point?
Yes, sir.
Yeah. Now we'll get to the
Yes,
question
sir.
someone has asked why it is a passive or why it is not active. So we'll go to energy, and we all know energy is integration of power. So energy, I'll call it E of t is equals to integration of P of t dt, right? Say T1 to T2. So integration of, or we'll just directly write the formula. We'll not consider time also. Integration of P of t dt. So P of t is C V of t dV of t by dt. So it is integration of C into V of t into dV of t by dt into dt. So this dt dt get cancelled. Now we'll have C into V of t into dV of t. We are integrating with respect to V of t. Then this will be C into V square of t by 2. So energy E of t is half C into V square, right? Agree? 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 Do you agree or not? Yes. So now is this energy always positive or it can be negative? Or what do you think? It is always positive or negative, or it can be both?
Positive, sir.
Yes, it is always positive. So if the energy is always positive, then we have mentioned that it is a passive element. So that's why capacitor is a passive element. Understood for us or whoever has asked? Fagim, sorry. Yes, okay. So now we'll quickly go into the power and energy in the inductor. So power and energy in the inductor. So why no one is active today? Everyone seems dull and no one is responding. Is it boring or should I go a little bit fast or am I going fast? Should I go a little bit slow? Feel free to say anything. If you feel I'm going fast, I'll slow down. If you feel I'm going a little bit slow, then I'll speed it up. No, sir, it's okay. Okay. Plus minus V of t and I of t and inductor. So same thing we'll do. P of t is equals to V of t into I of t. Then V is nothing but L into di of t by dt into I of t. Then we'll get P of t is equals to I of t into di of t by dt. Now again, same scenario. Depending upon the power polarity, it can be either positive or it can be negative. I have forgotten L. Again, we'll get similar kind of table. So let me just copy this table and then use. So capacitor and inductor are more or less same, right? Yeah. What is the only thing that will change? Here it is V of t and here it is I of t. So we'll have I of t and here we'll have d different derivative of I of t. Depending upon the power, again, polarity of power, either it could be absorbing power or it could be delivering power. Now, let us go back to energy. And energy also, it is almost the same. You can always see that uh, capacitor and inductor are always analogous. If it is voltage in one case, it is energy in another case. If it is, I mean, voltage in one case, it will be current in the other case. If it is current in one case, it will be the voltage in the other case. So here we have C into V of t into dV of t by dt. Instead of capacitance, we have L. Instead of voltage, we have current. So I of t into di of t by dt. So let us replace it. So instead of C dVt by dt, we have L into I of t into di of t by dt into dt. So dt will get cancelled. Then we'll have I of t into di of t. Here L. Here Li square by dt. So we have L into I of t into di of t, which is L into I square t by 2. So again, we'll get the same thing, half Li square. Instead of half Cv square, we'll get half L into I square T. Again, energy is positive. So it's also a passive element. So if you want to see, these elements are passive elements. So for a moment, they can deliver power. But when will they deliver power? First, they have to absorb power. So first, they have to charge up. So they will first take some power and then only they'll deliver power. But overall, they are passive elements. So they cannot deliver energy. They'll only take the energy. So for some time, they will absorb power and then they can deliver power. But they cannot deliver energy. So that's why they are passive elements. So power is different, energy is different. So energy uh, decides whether it's a passive element or an active element. If energy is positive, it is passive. So R, L, and C, all three are passive elements. When it comes to power, whether they can deliver power or absorb power, they can deliver power. But before delivering, they have to absorb power because they don't have power directly. So any in capacitor or inductor, initially they'll start with a zero voltage or zero current, right? So initially the power is zero. So when the power is zero, how can they deliver power? They need to have some power, right? So that's why they'll charge up first. So they'll absorb power for some time. They can absorb power for some time and then only they can deliver. But in the case of resistor, power is also positive. So it cannot even deliver power. It can only absorb power. It cannot deliver power at any in any case. So that's why power in a resistor is always positive and it always absorbs power. Whereas LNC can absorb power for some time and can deliver power. However, energy is always positive, and that's why they're passive elements. Is that clear? Any queries until this point? Anyone?
Sir, it's clear.
Yes. Okay.
Sir, it's clear. Sir, actually, just I have one doubt. Sir, I have gone through the solutions of assignment 1 and 2,
Okay.
but there were no detailed solution were given, sir.
Okay.
It's difficult to understand, sir. If it is possible to have detailed solution of the
Okay.
previous assignments, it will be helpful.
Okay. Previous assignments
Uh,
meaning this year or past year?
no, no, this year,
This year.
assignment 1 and assignment 2. Yes,
Okay.
sir.
The
Only the
solutions are not
correct
clear.
options are given. Yes, sir.
Okay.
Detailed solution, it will be helpful, sir.
Okay, okay. Actually, we had a discussion with the course instructor, and course instructor had told us to solve the problems in these problem solving sessions. But last week I was out of station completely, and I did not get time to interact with the other TAs. But today I'm going to discuss with them and see if we can solve few problems. So I think 10,
No,
10 or
sir.
12
Actually,
questions.
I'm not. No, no,
Yeah.
sir. I am just asking when the solution they are uploading,
Uh,
it is not the detailed solution, only giving the option in the answer.
uh,
Means in the answer section,
yes.
it would have been beneficial if the detailed solution was uploaded.
Yes, yes, yes,
We
I
can
understand.
go.
Actually, for
Yes,
that
sir.
reason only, Sir said as the detailed solution will not be uploaded, he wanted us to solve in this class so that if any of the students
Oh,
have
okay.
any doubts, they can directly ask, right? So even if the detailed solution is given, you might have some doubts here or there. So that's why he wanted us
Yes,
to
sir.
solve it in the live so that if someone has
Yes,
doubt, it will be clear and this always remains in the on the YouTube forever. So if you have any doubt, you can always go through this video and you can check it again. So that's why he wanted us to solve. But we have not
okay, sir.
coordinated with the other two TAs. I have not coordinated, but I'm planning to
Okay.
solve it. So probably you can expect in the
Yes, sir.
next
Yes, sir.
week four, we'll solve problems. So it's not like
Yes, sir.
we have to decide how we are going to solve. It may be that each TA will take 1 week. So like week one TA might solve, week two, 1 week, my one TA might solve. That we'll decide and we'll
Yes, sir.
check. But all the questions will be solved. Don't worry. And thanks for raising this query.
Thank you, sir.
Uh, Now we'll quickly go to the voltage source and current source. How inductor and capacitor are analogous to each other. Similarly, voltage and current sources are analogous to each other. In one case, it is voltage. In the other case, it is current. So power and energy in a voltage source. Here I'll just quickly go through because we have spent enough time in R, L, and C. So if we consider a voltage source, so we have V is constant and current I, right? So power P of T is, sorry, I made a mistake here. Current is in the downward direction according to our earlier convention. So let us just stick to that convention. So P of T is equals to V of T into I of T, and V is constant, so I write it as capital V into I. Now current can be positive, current can be negative. Agree? Do you agree? Hello?
Yes, sir.
Yeah. So now again we'll get this same scenario. Again there is less than a minute. This meeting will end. Kindly join back so that we'll continue our discussion. So we'll have two cases again. One is P greater than 0, one is P less than 0. So it can be absorbing, it can absorb power or it can deliver power. Now, if you see energy, E is equals to integral V into I into dt. And say V is constant, I'll bring it out. V into integral I into dt. So I can consider a scenario where current is constant and it is positive, or current is negative and it is constant. So energy can be positive and energy can be negative as well, right? So it can absorb and it can deliver power. So it can absorb slash deliver power. So that's why it's an active element, because we cannot get a condition saying that it is always positive or it is always negative, because it can be both. There can be a scenario when it can be positive, there can be a scenario where it can be negative. So that's why it's a, sorry, I'm very sorry, it's an active element. It can absorb and it can deliver it. So it is an active element. So someone has asked, sir, why the current direction is inside. So that is the convention that we have considered in the beginning. Uh, if this is the direction of the current, then power greater than zero means absorbing power, power less than zero means delivering power. If the current is going out, then what will happen? P greater than zero means delivering power, P less than zero means absorbing power. So whatever theory that we are creating or building here, it should it is always based on some convention, right? Voltage, polarity, and current direction. So this is the voltage, polarity, and current direction we have assumed in the beginning, and all the uh, theory that we are building is with respect to this. So if this thing changes, then all these things will change accordingly. But it is just for our understanding that when do we say it is absorbing power? It draws the current and the voltage is polarity. Polarity is positive. When do we say it is delivering power? When it is supplying the current with respect to this voltage polarity. So it is always dependent on the direction of current and the polarity of voltage. So that's why we have fixed the voltage and current, and from there we are checking what is the sign of power, whether it is positive or negative, or it is always positive. And accordingly, we are building all the theory and formulating this theory accordingly with respect to that. So a voltage source, it can absorb power or it can deliver power, and it can absorb energy and it can deliver energy. I'm sorry, I have made another mistake. So this is energy, and that's why it is called, it is an active element. So it can deliver as well as uh, absorb energy depending upon the situation. Now, similar thing for current source, only uh, current will be replaced by voltage, voltage will be replaced by current. So let us just keep it here. I'll just slightly change. So this is a current source. Okay. And current is positive, and say the polarity is this, and it is V of t, and the current is constant. Or I can directly write it's a constant current, so capital I. So here, how it will change? Our voltage will be small and the current will be capital. Okay, and again, P greater than 0 means absorbing power, P less than 0 means delivering power. And how this expression will change? V equal to integral I dt. Here current is constant, so current will come outside and it will be the integration of voltage, V dt. Again, it can absorb energy, deliver energy, because say voltage is negative, current is positive, voltage is negative. Then integral of a negative number is negative. Overall product will be negative. So it can be negative or it can be positive. V and I are positive, then it can be positive. So it can also either absorb energy or it can also deliver energy. So that's why it is called an active element. So is this clear until this point? We have discussed about power and energy of few electrical elements, starting with resistor, followed by capacitor, inductor, voltage source, and current source. So is this clear until this point? Power related things. If you have any query, please
Yes, sir.
ask. Yeah. So after this, Sir has discussed about a few circuit analysis methods. So Sir has discussed about something called node, tree, branch, and co-tree, all these things. Have you gone through these lectures, whatever Sir has taught in this week? Hello. Yeah, please be like honest. If you have understood, then I'll go a little bit fast. If you have queries, then I'll go a little bit slow. Yeah. No, sir. Yeah. So you should always tell the truth, because if you need some help, then I'll spend more time so that your concept is clear. And if your concept is clear, then I can just brush up. As it is not clear, I'll spend some time. But before that, I would like to show you that previous semester I have discussed a separate video. I made a separate video which is week 8, and it is related to graph theory. So there are many sections like where I have explained what is a graph, what is a tree and co-tree, and some methods also. You can skip this part, but at least go till tree and co-tree. I have made an example and I have clearly explained. So I'll give you the link of this week. So you start from the beginning and go till these two chapters. So introduction, what is a graph, and tree and co-tree. You go through these three chapters. Again, I'll quickly go through these things today. But if you still have any doubts, you please go through this week. And I'll also mention this in the chat box of this week 3, which I'll be uploading. Okay, so let me just share the link of this. As the video is already made and I have explained it clear, that's why I'm giving. So if you have any queries, you can go through. But I'll also explain it today. To everyone. Okay, I'm mentioning it in the group chat. Please let me know whether you have received it or not. You received it, right? Okay, sir. Okay, got it. I'll also quickly go through the circuit analysis concept. It is very simple. It is graph theory, and it is used in computer science as well. But it is also used. It can also be used in the network. It is just a theory, which is a generalized theory, and it can be applied in many applications. People apply in coding, and people apply in circuits as well to solve for voltages and currents. So I'll take up the same example that sir has considered in his lectures. So I'll use the same thing so that if you have any doubt there, it will be clear. So let me take the same example that sir has considered in his class. So sir has considered 8 elements, I think. So let me draw the same. He has considered initially all resistors, but it need not be all resistor. But for some simplicity, he has considered. So two resistors, and then another resistor here, and another resistor here, and another resistor here, then voltage sources, and one resistor here, one current source, and another current source. So how we have to identify nodes? This is one node. Let me use a different color. So this is one node, this is another node, this is another node, this is another node. So nodes, I will write it as 1 2 3 4, 1 2 3 4. So these are the nodes that sir has considered in his video. We are also using the same thing. So 1 2 3 4. Now let us consider the elements. So there are how many elements? 8 elements. I'll use the same numbering what sir has used. 1 2 3 4 5 6 7 8 6. So sir has considered current source and resistor as elements, but it can be inductor, it can be capacitor, it can be voltage source, it can be a combination of any of those things. But for some simplicity, sir has considered a very basic circuit, but it can be a combination of all these three as well. So here we have considered 4 nodes and 8 branches, but we can develop the theory for generalized theory, I mean generalized circuit. So we can consider any circuit with n nodes and b branches. So here, what is the value of n? In this case, in this 4 branches are 8. Branches are nothing but the elements that are considered between two nodes, a set of elements. It can be a combination of resistor, inductor, voltage source, current source. Here we have considered each element in a branch. So in this case, there are 4 and 8. So now tell me, each branch has a voltage and a current, right? Agree? Agree?
Repeat, sir, please.
So each branch has a voltage and a current, right? In this circuit, each branch, say this branch has some voltage, some current. This branch has some voltage, some current. Unknown values. This branch has some voltage and some current. Agree? So if I want to solve this circuit, I have to solve for the voltage in each branch and current in each branch. Agree?
Yes, sir.
Yes. So now if I have to solve for current and voltage in each branch, we have B branches. That means I have to solve for two B variables. How? Each branch has one voltage, comma, one current in each branch. So there are n branches, which means we have to solve for B voltages and B currents. B is the unknown. Here there are 8 branches, which means I have to solve for 8 voltages and 8 currents. So we have to solve for two B variables, which means we need two B independent equations. Agree? So n equations, like k
Yes.
equations, k unknowns, right? Agree? So this is the thing that you should keep in your mind. As a circuit has B branches and each branch has one unknown voltage, one unknown current, we have to overall find out two B variables, B voltages and B currents. That is what we are planning to solve in a circuit. So as we need two B unknowns, we need to have two B independent equations. Now, how do we get these two B independent equations? So let us just whatever we have learned, Kirchhoff's laws that we are going to use, and we are going to solve for this two B independent equations. So first we'll get three such. What we'll do, we'll be doing KCL at every node. Then we'll apply KVL in every loop, and then we'll apply IV characteristics in every branch. Got it? So these three are the voltage current relationship equations which we'll get by applying Kirchhoff's law. And using these three, we should get 2B independent equations. So now I know KCL, I know KVL, and I know IV characteristics in every branch. Say some branch has resistor and inductor. I know that voltage across the resistor is I into R, and I know the voltage across the inductor is L into dA by dt. So that will give me one equation, right? Similarly, in every branch, we'll apply IV equation. So each branch will give one equation. Agree? Agree? Hello?
Yes, sir.
Yeah. So if there are n, how many branches? B branches. So we'll get one equation in each of these branch. So how many IV characteristics I'll be getting in total?
Yeah.
Any? How many? How many? Anyone? Like each branch, I'll be getting one IV equation, right? So if there are B branches, how many total IV equations I'll be getting in that circuit? Each branch will get one equation. we'll get B equations, right? Because there are B branches and each branch will get, yes, Roshan, you are right. So we'll get B equations, B number of equations. Okay. So now first we'll go to the KCL at every node. So if you apply KCL at every node, how many nodes we have? We have four nodes, right? Let me just copy this. So you apply KCL here, KCL here, KCL here, and then KCL here. So if you apply for n nodes, say n nodes, if you apply KCL equation, if you apply KCL, then you will get n minus 1 independent equations. Why n minus 1? That sir has discussed. I'm not going into that much detail, but n minus 1 independent equations. Right. So if I apply KCL at every node and we have considered there are n nodes, I will be getting n minus 1 independent equations. So KCL is dependent on the nodes because you apply at every node. And once you do, you will get how many equations? N minus 1. So we'll be getting n minus 1 equations, independent equations. We are talking about independent equations. Yes, I know that we'll be getting overall how many equations? N equations if you apply. But how many independent we need? We need we'll be getting n minus 1 independent equations. Because one equation will be redundant, and why it will be redundant, that sir has explained in detail. As we are running out of time, I'm not going in that much detail. But yes, you please look at sir's video, or you can consider one small example and you can see that if you have three equations, then you can get this equation, which means this equation is redundant. So one equation will be redundant, so we'll have n minus 1 independent equations. Okay, so from here I got n minus 1 equations. And sir, no numerical based on graph theory is given in this week assignment. Roshan, thanks for pointing this out. The assignment that I have planned to solve today has some questions related on graph. So I'll plan to cover those questions today. Then I think it will be very easy for you to understand the concept that we are discussing. Thanks for pointing it out. I'll solve the questions. Even if it is not there in this week, it will be there in the final exam. So we should be solving, and we'll solve today, and I'll solve three problems on the same. So we have IV characteristics in every branch, B equations, and here we have n minus 1 equations. Now KVL is applied in every loop. So how will I know how many loops are there in big circuit? I can see here there is one loop, here there is one loop, here there is one loop, here there is one loop. But how will I know that how many loops? So for that only, uh, some theory called graph theory is applied. So, so even if while watching this video, I'll try to keep the link on this right top corner so you can access that, and I'll also mention in the chat box. So you can go through that video, and if you have not seen that video, I have mentioned it in the chat box in the top. I'm mentioning it again, where I have mentioned about tree, cotree in detail. We'll not go in that much detail today. We'll just cover the concept quickly. So graph is nothing but each element is represented by a single line, right? So if I represent it as a line, we'll get something like this. So this is called like a skeleton or a graph. Okay. So we'll use the same the notation. These are nodes. 1, 2, 3, 4 nodes. 1, 2, 3, 4 nodes. And we have elements or branches. 1, 2, 3, 4, 5, 6, 7, 8. So this is called a graph. This is called a graph. It is like a skeleton of the circuit. And kindly go through that link that I have provided, then you'll understand better. Say skeleton of the circuit. Okay. So when we have graph, first we need to identify a tree. What is a tree? Tree is a path touching all the nodes, and it should not form any loop. So tree is set of branches traversing through the nodes without forming a loop. So let me put down the definition. Tree is a set of branches traversing through all the nodes without forming a loop. So there can be many trees, right? So let us say element 2, element 3, element 7. I'll consider one simple example. So this is a tree, right? And let us take this graph onto the new page. And tree is what? A set of elements traversing through all the nodes. So I'll consider one example. Say, and there can be n number of possibilities. I'm considering one such possibility. So this is 1, this is 2, this is 3, and this is 4. No loop is formed. This is 6, this is 3, and this is element 4. So now this is a tree. Understood until this point? Hello? Hello? Any query until this point? Is it clear? Someone has mentioned. Yes, sir. So now, what is a co-tree? The elements that are not covered in the tree are branches of co-tree. So I'll mention co-tree with the dotted line. So here we have one branch of co-tree. Here we have one branch of co-tree. Here we have two such branches of co-tree. Here we have another branch of co-tree. So this is 8. This is, so I'll use a different color so that there will not be any confusion. I'll use uh, light blue color. So this is 8, sorry, this is 8, and then this is 7, this is 2, this is 1, and this is 5. So with the tree that is there in the red color, if you consider any branch of co-tree, say 1, then a loop will be formed. Like, I mean to say, if you consider any tree, like if you consider a tree plus any branch of a co-tree will form a loop. So the number of now I know number of loops in a circuit is equals to number of branches in a co-tree. Because if I add one branch to a tree, then it is forming a loop. So now I know if I have to find out the number of loops, then I have to find out the number of branches in a co-tree. So first we'll find out number of branches in a tree. How many branches are there in a tree? Each branch in a tree is connection between the two nodes, right? So we have 4 nodes and we got 3 branches. So we know the number of branches in a tree is equals to n minus 1. Understood? Because we are connecting the branches between the nodes. So it is always 1 less than the number of nodes. Agree? Hello?
Yes, sir.
Okay. So number of branches in a tree is n minus 1. And how many uh, how many branches in a core tree? How will I get? First, I'll write a number of branches in the circuit. Total number of branches. Total number of branches is equals to how many branches we have? B. Now, number of branches in a core tree. How many will have? B minus n minus 1. Agree? Total number of branches minus branches in the tree is the branches in a core tree. Total number of branches minus this red color will give us the dotted color branches. Here, how many total branches we have? 8. Minus how many we are subtracting? 3 will give you how many? 5, which is 1, 2, 5, 7, and 8. Agree?
Yes, sir.
Yeah. So now we have seen that number of branches in a core tree is equals to number of loops. So we have number of loops, which meaning number of KVL equations is equals to B minus n minus 1. So the number of KVL equations that we will be getting in a circuit with B branches and n nodes is B minus n minus 1. So let me just write it here. So we have B minus n minus 1. Okay. So these are the equations that we'll be getting by applying KCL, KVL, and IV characteristics in every branch. So how many equations we are getting in total? So we are getting in total how many equations? N minus 1 plus B minus n minus 1 plus B. So how many equations in total? 2B, right? This is 2B, right? This will get cancelled with this 2B, which is the same thing as this. Got it? So we are just trying to
Sir,
prove.
here,
Yeah.
here we are just getting the number of equations, but
Yes.
ultimately to solve the network, we have to write the equations.
Yes.
Uh, so how it is beneficial, sir?
Yes.
Means,
Yes, I'll come back. So, very good question. So, when we are going to do with graph theory, we'll first get all the equations and then we'll write in terms of matrices and we use that matrices to solve. So, I'll just quickly refer to my old video. Here I have mentioned nodal analysis using graph theory, mesh analysis using graph theory, cut set method using. So, these three are the methods that you can use using graph theory to solve any circuit. So let us go to one of the video. And if you see everywhere, we'll be writing in terms of matrices. Just let me show. Yeah. So, so here everything I'll write in terms of matrix and then I'll be solving. I think somewhere I'll solve, write, summary would be good. Just let me show. Huh. So if I will be using graph theory, I'll be using one of these methods and I'll use one of these equations to solve. So everything is written in terms of a matrix. And how will I solve matrix? We'll discuss that theory, how to solve this graph theory using that matrix. And if I have 100 cross 100 matrix also, I'll plug into a computer. I may be using MATLAB. Then I'll solve those equations. Because if I have AX equal to B, then I can solve for X, right? You know that theory. If you do not still know and if you are curious to know, you can go through this week 9, which is in the network analysis where I have explained how to solve using this matrices solution for a given network using graph theory. How to solve? I have explicitly mentioned here. As this is already available in the YouTube, I'm not covering. Probably sir will be covering these aspects in the upcoming weeks. So yeah, please wait till that is covered. But if you want to see how graph theory will be helpful, then you can also solve. You can go through this week 9 where I have solved problems using this graph theory and how graph theory can be used to solve it simpler. The main issue is the direction. What is the polarity? Say the main issue with the circuit is if it is getting complicated, you cannot do it manually, right? You need a computer to do it. And once the computer is doing it, you have to give it equations, right? And how you will be giving it equations? You cannot do it all the equations. You cannot do it by yourself and then get the to be independent equations, right? There should be some theory which will directly give you the equations. So using graph theory, just by looking at the circuit, given circuit, you can write the equations or the elements in a matrix. So that theory we are going to discuss in the upcoming weeks. And if you want to go through, you can go through my network analysis week 8 and week 9 lectures where I have explained how to solve using graph theory. So looking at the circuit, first we'll write all the to be independent equations, and then we'll use a computer to solve those independent equations. So we are creating like a process, or we are creating some kind of steps to solve that complicated circuit, because everything we cannot do it manually. Neither we can write the equations randomly and give it to a computer. We need to give it to a computer in a certain format, which is ax equal to b, and then it will solve for x, but we should do it properly, then only we'll get. So for writing the equations in terms of ax equal to b, it itself is not an easy task, and we need to have some proper theory based on which we'll write those equations in an easier way. And those equations you can get by applying graph theory. So that's why we are understanding about graph, and we'll slowly get into the details of this theory and how this theory will be applied to solve an equation in the upcoming weeks. If you want to know beforehand, you can always go through week 8 and week 9. Week 8, I have explained the theory of how circuit methods can be used to basically about the circuit methods to get some equations. And in the week 9, I have shown how those equations can be applied to solve a few problems. Yes. And there is one more small thing which I'll take 2 minutes time, which is called superposition theorem. What does superposition theorem? First of all, it is applied only to linear elements. So if there are multiple sources in a circuit, you can consider one at a time, and you can combine the solution. You can add up the solution. So effect of multiple sources. Effect of multiple independent sources, because we have also considered dependent sources. Effect of multiple independent sources, if they are all of there are there in a circuit. Say it can be voltage, it can be current. There are say three voltage sources and three current sources. So all of these things acting together, this is nothing but sum of the effects of these independent sources considering one at a time. So it is nothing but the sum of the effects of the independent sources acting one at a time. So this is very important. So if I have voltage sources, three voltage sources and two current sources, I will consider one voltage source at a time. So and what happens to the other voltage sources or other current sources? So if you want to remove the effect of voltage source, you have to short it. like zero voltage source, you basically short it. And what happens to the current source? You open it, which means zero current. So in the end, I have just gone a little bit fast, but it's okay. Even if you do not understand, we'll get you into it in the upcoming weeks. This is just briefly explained in this week, so it is okay. We have 3 more minutes before this meeting ends, so let me just summarize what we have discussed in today's class. Then we'll go to problem solving session. So in the beginning, we have discussed about power and energy in a circuit element. We have generalized some theory and discussed what is absorbing power, what is delivering power, and we have also seen the energy expression. Then we have discussed about power and energy in the resistor. We have realized that it can only absorb power, and the energy is always positive, which means it's a passive element. And then we have seen the energy and power in a capacitor, and we have seen that it can either absorb power or it can deliver power, but the energy is always positive, and that's why it's a passive element. Same thing happens in the inductor. It can also absorb power and deliver power, but it can only uh, deliver. It can only absorb energy because energy is always positive, and that's why it is a passive element. Voltage source can absorb power, deliver power, absorb energy, and deliver energy, similar to the current source, which can also absorb and deliver both energy and power, and that's why these two are active elements. Then we have discussed about circuit analysis. We have started with n nodes and b branches. In this case, there are four nodes and eight branches, and we have seen each branch has one voltage, one current that needs to be solved for. So we'll have 2b variables, which means we need 2b independent equations. And how we'll be getting? We'll be getting from KCL, KVL, and IV characteristics of each branch. So how many KCL equations we'll be getting? If there are n nodes, we'll get n minus 1 independent equations. So n minus 1 equations here. And IV characteristics, if there are b branches, we'll get one equation per branch. So b equations. And how to get a number of loops in KVL? We have started with the graph, and then we have discussed something called tree, and then we have realized number of loops is equals to number of branches in a core tree. And how many branches are there in a core tree is total number of branches minus total number of branches in a tree, which is b minus n minus 1. So here we'll be getting b minus n minus 1 equations. So the total number of KCL equations are n minus 1, this is b minus n minus 1, and this is b. Totally we'll get two b independent equations. There is less than a minute. If this meeting ends, kindly join back, then we'll do problem solving session. So superposition theorem says the effect of multiple independent sources acting together is just the summation of effects of these independent sources acting one at a time. And if only one is acting, other voltage sources will be shorted and other current sources will be open. So this is the summary of this week theory. Now we'll solve few problems. Any doubts till this point? If this meeting ends, please join back. Any doubts till this point? So we'll start the problem solving session. Sir, can you explain circuit analysis by taking an example? Graph theory important. Can we skip? Yes. Bhuvan, um, today we'll not be getting time to explain circuit analysis by taking an example, but I have two videos. One is week 8 and another is week 9. So let me share the. We'll be discussing the next. So let me share the links of these two videos that you can go through later. So this is week 8, okay, and I'll also share week 9, where I have taken one example in my previous semester NPTEL course. That is okay. So let me just mention in the chat box. Okay, so week 8 and week 9 you go through. And one more question, sir. Graph theory can we skip? Graph theory is the most important topic in circuit theory. It is not just limited to electrical, it is having applications in other domains like computer science as well. So it is one of the most important theory that one should be learning, and you can spend time if you think that is little bit difficult, because this week it is more of power and energy and less of graph theory. So that's why I did not cover it rigorously. But in the upcoming weeks, I'll spend a lot of time on that and make sure that you understand it properly. So don't be afraid of graph theory. It is very important. Take it with utmost importance. Okay, I'll solve a few problems for today. So the first problem is this: determine the power delivered by the current source below. So this is our problem one. Okay, so this is our problem one. So how am I going to solve? So the initial idea is I'll find the effective resistance of this R effective. Can someone tell what will be the R effective? Then power delivery is nothing but I square R.
5 by 6.
How much?
5 by 6. 5
5 by
by
6.
6.
Okay. So let us just check. R effective is 1K parallel with. So this 2 plus 6. This 2 plus 6 is nothing but 2 plus 3 is nothing but 5 kilo ohms. So 1K and 5K are in parallel. So we have 1K into 5K by 1K plus 5K, which is 5 by 6K. Now I know that power delivered is nothing but I square R. So 12 milli into 12 milli into 5K by 6. So 6 means, so 6 is 2 milli. 2 milli into 5K is 10. 10 into 12 is 120 milli. So how much is the power? 120 milli, right? What? What? Agree? Very simple. I have found the effective resistance and then I have used P equals to I square R and then I have solved P equals to 120 milliwatt. Is this clear? This part, P equal to 120 milliwatt. Hello.
Yes.
Okay. So let us go back and check. Power is 120 milliwatt. So it is simple. Current direction. Okay. So they have asked the power delivered by the current source. So now, very good question. If there is a resistor network, only resistor network connected to a current source, then the resistors can only absorb power and the current source can only deliver power, right? Because resistors will always draw the power. So that's why current source that is there, it always delivered power. So that's why it is positive. But we'll get into the example where we'll get negative part, meaning power may be negative. It meaning it can be positive, it can be negative depending upon whether it is delivering or absorbing. And yeah, this is some simple question, so I'm just skipping it. I'll come back to it when we have time, but I'll cover very crucial and important questions, which are little bit complicated, just like this question, where we need to have some understanding to solve. So this is one very interesting question that we'll discuss today. So this is our problem two. So they have asked what is the energy delivered by this voltage source from t equals to 0 to t equal to 3 microsecond in this figure below. Okay, so first we'll every time we'll start with the definition that we have. What do we have? We have energy is equals to integral p of t dt. Say this is I1 of t, right? Say this is I2 of t and this is I of t, right? So if it is delivering, it means the current it is supplying. So that's why I have considered the current like this. So now the voltage source is delivering because the current direction is out of the element. It means it is supplying the current. It means it is delivering the energy. So that's why I have considered like this. And what is this P? P is V of t, which is 5.
L लेकर L माने 11 is
Sorry,
I take
I. Hello. Okay, so this is how we'll be getting, right? Voltage is constant and we have to find I of t. Agree? Hello. Hello.
Yes, sir.
Yeah. And I of t is nothing but area under the I of t curve, right? And what is I of t? If you apply KCL here, you will get I of t is nothing but I1 of t plus I2 of t, right? And they have given I1 of t here, and we have to find I2 of t. Then we'll solve for I of t, and then we'll find out the area of area under the curve to get E. Is that okay? Hello.
Okay, sir.
Yeah. So we have initially started from the question that they're asking how much is the energy that is delivered. So we have started with energy is equals to integral of power into time. Then we have seen power is nothing but voltage into current. As voltage is constant, I have taken it outside, and it is integral I of t, which is nothing but area under the curve I of t. And for getting I of t curve, I need to know I1 and I2, and they have given I1. So I have to find out I2 of t. So how will I find I2 of t? I know the VI characteristics of inductor, right? So V voltage across inductor is equals to L into di by dt, right? D I2 upon dt. So now we'll get I2 of t is equals to 2.5 by micro dt. So di2 of dt. So now I'll get I2 of t is equals to 2.5 t by micro, right? Or I can write 2.5 t in microsecond. T is in microsecond. Agree? I have solved for I2 of t. Is this part clear, or do you want some more explanation? Okay. If you have any query, please
So
ask.
please repeat, sir. So
Yes,
please repeat, sir.
yes. So the voltage across the inductor V is equals to L into di2 by dt, which is the current entering the inductor. So if you bring this 2 micro on this side, we'll get 2.5 by micro into dt is equals to di2 dt. Now if I do the integration, I'll have I2 of t on the left side, and the integration of 2.5 is 2.5 t. And if t is in, actually t is in seconds, right? But there is micro in the denominator. So I am writing t in microsecond. Here t is in microsecond. Here t is in microsecond. Got it? Just like this. Integration of 2.5 is 2.5 t, and in the denominator there is micro. So in order to cancel the denominator micro with the numerator micro, numerator should also be having a micro, right? So that's why here t is in microsecond. Understood?
Yes, sir. Yes.
Yeah. So now let me draw I1 of t. So this part is very clear. So I have I1 of t, I have I2 of t. Now we have to find I of t. So for that, what I'll be doing, I'll add the curves of both the things. So this is I1 of t, and in the question they have asked until energy till 3 microseconds. So I'll only bother about these currents till 3 microseconds. Okay, so this is 2 and this is -2. This is I1 of t, and the time is t, and this is 1 micro, this is 2 micro, this is 3 micro, and now this is I2 of t. So t is in microsecond, as we have specified. So now let us draw the same thing. So 2.5t means it is a straight line passing through the origin with a slope of 2.5. So the line will be something like this. This point, and this point. So this point is 2.5, this point is 5, this point is 7.5. Agree? 5, answer is 5. We'll go back to that point, but let us just not skip that part and we'll just see. Agree? Hello? Hello? Actually, this part I have made a mistake. So this is not, uh, it will be I2 of t minus I1 of t. So I of t is I2 of t minus I1 of t. I made a mistake in KCL because here we'll get current entering is I of t plus I2 of t is equals to, sorry, I1 of t is equals to I2 of t. So now I of t is nothing but I2 of t minus I1 of t. Sir, once can you repeat I1 part, sir? Yes, definitely. So I1, they have already given in the question. So at 1 micro it is having 2, at 2 micro it is having 0, at 3 micro it is having minus 2. And for I2 of t, we have seen that it is 2.5t. So it is constantly, I mean, it is increasing, right? It is passing through origin. So at 1 micro it has 2.5, at 2 micro it is having value of 5, at 3 micro it is having a value of 7.5. So now, in order to get I of t, what should I be doing? I should subtract I2 of t minus I1 of t. So this is the most difficult and important part. So pay it utmost attention and see what I'll be doing. So t, and this is I of t. So I have to subtract I2 of t, or I have to subtract I1 of t from I2 of t. So until 1 micro, the value, both of them are linear, and I have to subtract what I have to do, I2 of t minus I1 of t. I2 is going to 2.5, I1 is going to 2, so it will go till 0.5. So the equation is, the line is something like this. This is 1 micro, this is 2 micro. Okay, now I2 is increasing, I1 is decreasing. So the negative of I1 will be increasing. That I have to add with I2. So both will be increasing. So at this point, the value of I1 is 2 and this is 2.5. 2.5 minus 2 is zero point 0.5. So it will start with 0.5. And then at 2 micro, the value of this is 5. This is 0. So it will end with at 5. So at 2 micro, we have the value 5. And sorry, this is not 2 micro. This is 0.5 because 2.5 minus 2. And at 3 micro, we have 7.5 minus minus 2, which is 9.5. So it increases to the value 9.5. Got it? How I have solved for this? Or you have doubts?
Sir, from 1 micro to 2 micro, and please repeat.
Yes. So basically, I2 of t, this is the equation of I2 of t is something like this, right? This is I2 of t. And this is I1 of t. So this will be minus I1 of t, right? So now I am adding these two, this and this. If I add, I'll be having something which is having a very high slope because both are having positive slope. So this will be I2 of t minus I1 of t. So I know that it's a straight line and I have to find the middle points. So at 1 micro, I know that this is 2.5, this is 2. So 2.5 minus 2 is zero point 0.5. And now this is this, right? So this is from 1 micro to 3 micro. I know that this is the shape. So I have just finding 1 micro, it is 0.5, and at 3 micro, it is 7.5 minus 2, which is 9.5. And at 2 micro, it is 5 minus 0. So that's why it is 5. So is this clear, this part? Hello? Hello?
Yes, sir.
Yes,
Yes.
sir.
Okay. So now what you have to do is you have to find the area under the I of t curve. So I'll break it into small parts. So we have this area, and then we have this area, horizontal area, and then we have this area. Okay. So what is the base of this 1 micro, and height is 0.5. Here the base is 2 micro of this rectangle, height is 0.5, and the height of this triangle is 9. Right. So I will know that E is equals to 5 times in area under the curve, which is half into this triangle. Base is 1 micro, height is 0.5, plus area of the rectangle is 2 micro into 0.5, plus the area of the triangle, big triangle, is half into base into height, 9. Agree?
Yes.
Yeah. So now what is the value? 5 into this is 0.125, plus this is 1, plus this is 9 micro, right? So E is nothing but 5 into 10.125 micro. Can you tell what is the value of E? Sorry, this is 0.25. I made a mistake. This is 0.25. So this is 10.25 micro. Can you tell me what is the value of E? E is 5 is 25, 2. It is 10 plus 2, 51.25, right? Am I correct or?
Yes, sir. 51.25.
Yes. So if you find it difficulty calculating I of t, another thing you can do is, uh, maybe this could be easy for you. Instead of complicating things, you can write integral I2 of t dt minus integral I1 of t dt. So you can find area under the curve of this, and then area under the curve of this, and then you can subtract. That also you can do, which would be easy. I2 of t area under the curve minus area under the curve of this, which will be easy for you. But I would always prefer to draw the I of t, because here we want only area under the curve. But what if they ask something for which I of t is related? So that's why it is always a good practice to draw the waveform of the current that we are targeting for. So that's why I have drawn I of t, because if someone asks what is the slope here, then you should have this I of t, right? So that's why I have told. Maybe this question is a little bit lengthy as well as a little bit difficult, but that's why I have explained or taken up this problem today. So I'm going to explain it again. So if you have any doubts after the explanation, you can ask. So they have given one circuit like this, where they have given a current source, voltage source, and an inductor. They're asking what is the energy delivered. Energy delivered meaning it is supplying the current, right? I of t, and this is I2 of t. So I of t is nothing but I2 of t minus I1 of t. So energy is integral of power, and power is voltage into current. Voltage is constant, so integral IT dt. So if I get area under the curve, I have to multiply by power. I multiply by voltage 5 to get the energy E. So for getting the area under the curve I of t, first I need to know I of t curve. I of t is nothing but I2 of t minus I1 of t. I1 of t they have given, I2 of t I am supposed to find. So for calculating I of t, I have seen that there is an inductor here and I know the VI characteristics of the same. So V equal to L di by dt, and I have calculated I2 of t from which I got this curve. So if I have I2 of t and I have I1 of t, I know that I of t is nothing but I2 of t minus I1 of t. So I have used these two graphs to generate this graph, and I know the area under the curve of this I of t multiplied by 5 will give me energy. So that's why I have multiplied 5 into this to get 51.25. So the answer is 51.5, 51.25. So is this question clear? I also request you to solve it by yourself again so that you will feel more confident and you will understand it better. Is this okay, this question, or do you have any doubts until this point?
Okay, sir.
Okay. Now maybe if question 5, yeah, question 5 will solve. Question 6, 7 are also good, and then we'll solve 9 and 10. Okay. So first let me solve question 5. So first we have to see what they have asked, and then we have to use the formulas that we have and the knowledge that we have learned from today's class, and then we just have to apply without making any mistakes. So this is problem 3. So these are all the key terms that you should keep it in mind. Power delivered by the current source. So how much power that is delivered by this current source. So when current source is delivering, so let us just quickly go back and then see the polarity. Current delivered by the current source, right? So now just a minute. So here it is a current source, not sink. So I have made a mistake. The current source should be like this, right? So if it is delivering power, then is sorry, I think the previous one is the correct. Yeah. So now, if a current source is delivering power, then what should be the polarity of the current? So if a current source is delivering, it means it is supplying the current, and also it should have a positive voltage, right? So here they have given in the downward direction. So current source is like this. So polarity of the voltage should be like this, and I. So power delivered is equals to V into I. So this is what we are targeting for, and this is what we are supposed to calculate. So the voltage we need is this voltage, plus and minus. This voltage we need. And how will I get that voltage? Can someone tell what is the value of that voltage?
Minus of 2K IX.
Minus of 2K, and Ix is 4 milli. So how much is that value? Minus 8 volt, right?
Yes, sir.
Yeah. So now what is the value of power? Power is equals to V into I, which is minus 8 volt into 4 milliampere. So what is the power? Minus 32 milliwatt, right? Agree? Hello.
Yes, sir. Yes, sir.
So let us see. The answer is minus 32, because here basically it is not delivering, it is absorbing. So that's why
Absolutely.
delivered is negative. If they ask what is the power absorbed, then it means it is positive. So let me also write that, which is very crucial. Power delivered and power absorbed is minus 32 milliwatt, and this is plus 32 milliwatt. So is this question clear, or any doubts until this question?
Yes, sir.
Clear. Okay, then we'll solve one very tricky question which seems difficult, but it is not. So can someone give me idea of how to solve this question? So they have asked what is the energy delivered by the current source. So what should be the voltage polarity? This is how it should be. V of t, say V1 of t. Because we have mentioned it here, this is the polarity. So first I have to find V of t, I of t, then energy is nothing but integral I1 of t, V1 of t dt, right? Agree?
Yes.
Yeah. So now can someone tell me what is the value of V1 of t?
Vx.
Vx, just this is also Vx. Okay. This is also Vx. Huh. Now can someone tell me what is the value of Vx? I mean, sorry, V1, V1.
0.
Others, do you agree with him?
Two.
Who said zero?
Yes, sir. Zero.
Roshan?
V1 minus Vx plus Vx equal to 0. KVL equations.
Yes, sir.
Yes.
Zero. Okay.
Yes. Yes. You are absolutely right. V1 is 0. And how V1 is 0? Let us apply KVL. So I'll start from this point and then I'll traverse through the loop in this direction. So I'll have plus V1 minus Vx plus Vx is equals to 0, which means my V1 is equals to 0. So now what is the energy? What is the
Zero.
energy? 0. Yes. Energy is 0. Yeah. So here they have given a complicated question, but sometimes we think that okay, this question seems complicated, let us skip. But it doesn't take even a minute. So sometimes we should not make that mistake. We should see whether it is actually complicated. Say if this is this question, and if you have less time, then probably you can skip to solve some other question which is easier because there you can score marks. But this question, there is nothing to solve. You just have to see that V1 is 0, so answer is 0. So in the exam, this is what is more important, the number of marks that you score per minute. So you should save time and score more marks. Okay. And yeah, we'll solve this question, which is also very important. Or we don't have much time, or let us solve it anyway. This is question 5. So they are asking what is passive? Question 5. So uh, passive. What does that mean? It means energy is positive, right? So if power is positive, then E is also positive because E is equals to P into T. Agree?
Yes.
Yeah. So now in the question they have asked identify the elements that are passive. So tell me in which, okay, let us go one by one and then let us keep mark. So whether A power is positive always or power can be negative. So tell me which one, I will just ask whether P is positive or not. You just tell me yes or no. Whether A, P is always positive or not. So when will A be, okay, let me give some more hint. When is P positive? When either I and V are positive or both I and V are negative. So this happens in which quadrant? Quadrant 1, and this happens in quadrant 3. So the uh, figure should lie completely in quadrant 1 and quadrant 3, right? So which is what area? So if this is the IV curve, it should completely lie in this region or in this region, right? Because this is Q1, Q3. So now tell me which comes under, does A come under this picture or no?
No.
No. B,
Yes.
C,
No.
D, D,
No, sir.
No. No.
E,
Yes.
F,
No.
G,
No.
H.
Yes.
Yes. So these are passive, rest are active. So B, then E, and then H. These are passive. So sir has also discussed from in terms of graph how to determine or decide which one is passive or not. So B, E, H. So that is the answer. This question I'll skip. They are just asking the power delivered, but this question is crucial. The number of independent KCL equations. So we have discussed question 6. So this is question 6. So we have discussed the number of KCL equations in our theory is nothing but n minus 1, where n is the number of nodes, right? So how many nodes we have here? Can you tell me how many nodes? Is this a node? Hello?
Yes, sir. Yes, sir.
And this one? These two are a node, right? This and this are same.
Common name.
Yes, these are. And this is another node.
Yes.
And this is another node. All these bottom are single node. So am I missing any nodes, or how many nodes are there? Hello?
Four.
Four nodes, right? So 1, 2, 3, 4. So number of KCL equations, independent KCL. So number of independent KCL equation. How much independent KCL equation? N
Three.
minus 1, right?
Three.
So 3. Okay. Is this clear how we are getting the number of independent KCL equation? We have seen it is number of nodes minus 1. So number of nodes are equal to 3. So the number of nodes are 4. Okay. Any queries in this question? Hello.
No, sir.
Okay.
Clear, sir.
So we'll solve the other question, which is the number of KVL equation. This is the question 7. So how many KVL equations we have? Number of KVL equations is equals to, where is the theory? B minus n minus 1, right? Agree? That we have discussed in the theory. Hello.
Yes, sir.
Okay. So now how many nodes we have? 1, 2, 3, 4, right? So n equal to 4. Agree?
Yes, sir.
So now we have to find the number of branches. So number of branches is between two nodes. How many branches are there? So this is one branch. This is another 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 branch, right? Say this is one node, two node, three node, four node. So how many branches are there?
8.
Someone said four. There are eight branches. So one, two, three, four, five, six, seven, eight. Eight branches. So now can someone tell how many number of KVL equations? There is less than a minute. So if this meeting ends, kindly join back. Number of KVL equations, how many? Someone mentioned in the chat 5, Bhuvan. Let us check. 8 minus 3. It is 5. Yes, you are right.
Sir, it can be also seen by observation of the circuit. We can also show
How?
number of closed loops uh,
Yes.
by seeing the circuit number of closed loops. How many equations it can form?
Okay, and how are you saying so? 5.
So looking at the diagram, see first loop for one loop, one equation, second, three, four, five.
Oh, yeah, that also you can say, but it is not always true because yeah, as someone has said, sir, there are five loops, but I can directly apply that there are five loops, so it is five, but it is not so straightforward because you are seeing only five loops, but let me tell you something. These are the loops that you are saying loop 1, loop 2, loop 3, loop 4, loop 5. But I can also consider this loop and I can also consider other loops. Now the question is how many such independent KVL equations are needed. So we cannot say whether they are independent or dependent. So it is not always so straightforward. So we cannot not say because this is also a loop, and then we have this also a loop. So there are n number of loops, and the outer one is also a loop. But the question is whether all of them are independent or only some of them are independent. So we will get a lot of KVL equations, but we want independent, which is the minimum number of KVL equations using which we can derive the other KVL equations, which are called dependent equations. So that's why it is not so straightforward. So that's why we have derived these from the tree and branches of tree, branches of core tree. So that's why we should always follow this, and that gave us the number of KVL equation as 5. So that's why it is 5. So yeah, this is the end of today's problem solving session. Do you have any other queries or doubts or anything that you'd like to add?
Sir, there
So
is one particular
is it the
question
number of
in
Sorry,
assignment
one by
number.
one. Sorry.
Sir,
Yeah.
there is one particular question in assignment number 4 where
Assignment number
that
4, week
circuit
4.
has, yes, sir, but there
Okay.
are two grounds in that circuit. But how is it practically possible?
Okay. Can you just share the image if you have that
Can we share it?
in
Actually,
the
it's
chat? In the
assignment
chat.
questions.
In the chat.
Oh, just a minute, sir.
So until Vishnu shares someone who was asking the doubt earlier, can you please ask it now?
so actually what I was telling that there are number of meshes are five.
Yes.
So can we say that independent equation is equals to the number of meshes,
Yes, but
number independent
I'm
KVL equation?
yes, I'm saying this is also a mesh, right?
Uh,
This.
Sir, inside a mesh there cannot be a closed loop.
Yeah, yeah. You are right. Yes. That is also true. So then these are small meshes. That's what you were trying to say.
Yes, sir. Number of meshes, it can be thought of a number of independent equations.
Yes. Yeah, you are right. You are right.
Okay,
Yeah.
okay.
So in that way you can say, but because uh, this question is in the form of rectangle, it is very easy to look at the loops. But somehow, if they twisted it and if they have given in this kind of shape, then it is not so straightforward to see the independent meshes because it is somewhat clumsy. So in that uh, scenario, it would be difficult to identify. But yeah, in this scenario, yeah, you are right. Yeah.
Okay.
So the question that Vishwanath has shared, let me just, it is loading. Let me just see. Are you able to see the image? Okay, let me just. So someone in the chat has mentioned, yes, sir. Okay, Vishnu. So this is our doubt. So I'll write it as doubt. So I'll ask the students only first. If I have two such grounds in the circuit, what does that mean? Anyone? Is this practically possible, or is there any issue, or what does it supposed to mean?
Means you can consider it as a loop.
Yes. Who is this? Roshan or who replied? Roshan, is that you?
Me, sir.
Yes. Okay. Vishwanath. Okay. Yeah. So basically, what it means is this is also a ground. This is also a ground, meaning these two are directly connected. They are basically shorted, right? So I can say this is also a ground, right? I can say this is also a ground. So basically, these are anyway shorted. This is also shorted. So basically, if they are saying this is ground, it means these two are also shorted because if this is having 0 volt, this is also having 0 volt. So that's what they mean. Yes. So that's what they mean. Instead of showing it as short, they have given it as a ground because they are connecting that terminal also ground, this terminal also ground. Ground and ground are shorted, so these two are shorted. Got it? Whoever has asked that out, Vishnu, is that clear?
Yes, sir.
Okay. Yeah. So
So,
then,
sir, we can neglect the battery and the resistance because this is no meaning as
yes,
it is zero potential.
yes, but I would not say so. So do you think I1 will be zero?
No, I1 is not zero.
Yes, so we cannot just take it out of the circuit. It is there, but the voltage, total voltage across that entire thing is zero, but I1 is not zero. So that is the like somewhat a trick here. We cannot directly take those elements out of the circuit because there is a wire connected across it because there is still some current flowing through that. So that's why it is like not so straightforward to assume that we can directly remove. We can only remove if the
Okay.
current is zero. If the current is zero, then it means basically no current is flowing through that. So we can remove. But if the current is flowing, then it has some effect in the circuit and we cannot remove. Understood?
Yes.
Yeah. So any other question? No question. Okay, then we'll end our session here. So in the week three, we have discussed a few aspects about power and energy of different circuit elements, and then we have also discussed about few circuit analysis theorems, superposition theorem, and then we have also talked about graph theory, a number of equations, number of independent equations. Okay, so with that, I will complete today's session. And I'll meet you again in the next week in our normal slot, which is Monday 6 to 8 p.m. for week 4. And all the best for your assignment 3 as well as assignment 4. See you in the next week. Yeah, thank you and good night.
Thank you, sir.
Yeah,
Good night.
thank you.